All right, so take a look-see at this first one. 3 groups of sunflower plants are watered with salt water to see the effects on their growth. So we're testing the salt water. We want to see what it does. Okay, we're testing it. Each group of plant receives a different concentration of salt solution. So we got 25, 50, 75%. A 4th plant receives pure water. After a couple of weeks, the height is measured. Okay. So keywords I'm kind of seeing there. I'm seeing the word measured. We want to see the effects. I'm looking at percentages here. Okay. The independent variable. What is the thing that we are testing? We want to see what it does. What is the thing we are testing that we picked on purpose? Yeah, Jonah? Yeah, the percent of salt. So I'd probably slap a percent of salt right there. I want to be a little bit more clear. So that way Mr. P has no doubt that I know what I'm talking about, okay? So, and we chose that. We're like, okay, we're going to go with 0%, 25%, 50%. Like, we chose to do that because we want to see what it does. That's what we're testing. Now, what depends on how much salt we're using? What's that? Yeah, that's right. Yeah. I just didn't quite hear you, that's all. That wasn't like, what do you mean by that? I was like, I legit. What do you mean? Yeah, so the plant height, right? We're measuring that plant height. So, plant height, it depends on the salt. So again, what are we looking at? What are we measuring? What are we observing? It's the height of those plants. Now, what's our control? What would happen normally if we never did this experiment? What would have happened anyways?
The plant would grow. Okay.
There would be pure water.
Yeah, we would water them with pure water anyways, right? So that would be our 4th plant. Or some people could say plant with water with only pure water or something like that. Again, when we do an experiment, we'd be like, oh yeah, they grew so much more with the salt water. We'd be like, more than what? Like, I don't know. Like, how much do they grow normally? Oh, I don't know. I just gave them all salt water. Well, then how do you know they grew more? Like, you need to have something to compare them back to the normal. What would have just happened anyways? Okay? So there's that one. I want you guys to go ahead and try the next few. Again, today, if you have questions, that's fine. Please ask me questions. I'll be happy to help you. I'll be coming around. But by Thursday, we need to be able to dominate a bell work like this, okay? If you're watching this video at home, the answer key to this is going to be below the video along with the worksheet. All right, let's get her cooking.
Is this bell work doing this in class?
Nope. No, it's not. That bell work is practice for you. So if you didn't finish the bell work in class right now, you don't have to do any more of it because I'm not going to make you during class. But if you need to practice this a little bit more, you're feeling a little shaky, you should finish it up at home. And again, with these answer keys, I mentioned this yesterday. I'll probably say it a couple more times if people get used to it. Whenever you see an answer key in my room, it's always hole punch. That tells you, hey, you can just put it in your binder. If you want this, you can just put it in your binder and take it home with you. You want to take pictures of this? Go for it. And there will always be electronic copies in Schoology, okay? So let's say Ian goes home later today. He didn't take a picture. He didn't take it home with him. He's like, oh, man, I wish I knew the answer number 6. He can just go into the Schoology folder, week 3, since this is week 3. And if you just go into Tuesday folder, answer key will be right there, okay? So these are always just practice for you to dominate on your quizzes and tests. All right. So let's do one more of these. Let's see. How about the fish food one? So number 3. Tank of goldfish is fed the normal 5 grams of food once a day. So again, the moment I see the word normal right here, that's catching my attention. Yes, ma'am?
It's a control variable.
Oh, yeah, it definitely is. Yep. I got that in my head. The moment I see normal, I'm ready for it. A second tank is fed 5 grams twice a day, and a third is fed 5 grams 4 times a day during a 6-week study. The fish's weight is recorded daily. So, yep, I agree with Trinity right there. The moment I see normal, I'm like, okay, yep. Boom, that's for sure my control, the normal. What would have happened anyways if we never did this experiment? Well, fish would have been fed 5 grams of food a day. Fish, 5 grams of food. Probably would have been a little bit better if I said fish fed 5 grams of food. I'm running out of space. All right, independent variable. What is the thing that the experimenter chose to make different every time on purpose? Yeah, Emily? Yeah, so they're changing the amount of food, okay? So we gave some fish 5 grams, some fish 10 grams, okay? Or some fish 20 total, 4 times a day. So I would say amount of food to be more specific. Because that includes all the different amounts. Does that kind of make sense?
Yeah.
Nice work. Now, what depends on how much food the fish are getting? Close, not quite there. What was it? The weight. The weight will depend on. So the fish's weight depends on how much food they're eating. Does that kind of make sense? It doesn't matter who's feeding them, but it matters how much they're getting. So that's going to be the weight. Nice work there, Demetrius. Boom. And again, you're watching at home. The answer key to this is right below or in person. It's that pink sheet in front of you. All right, let's go ahead and move on to graphing stuff, okay? So you have a quiz on Thursday. Mr. P, what's going to be on that quiz on Thursday? Let me show you everything that's going to be on that quiz on Thursday. Here it is. This Thursday, you will have to draw a graph. That's what we're going to talk about today. You'll have to read a graph. We might do that today. I don't think we'll quite get there, but that'll be today or tomorrow. We'll probably do a little bit of practice on both. We'll see. And independent, dependent variables, that was Monday, okay? So we already did that one. That's what the bell work was over. We should be good there. Let's talk about how to make a graph, okay? So I'm hoping that this lecture is a little bit boring to a certain degree because I'm hoping it's mostly review where stuff like, yeah, I've kind of seen this before. Like, this isn't too crazy for me. Is there a question there? Yeah, go ahead. So let's go ahead and take a look at this. We have these data tables here. This one has time in seconds, and it has the distance a couple different rockets traveled. Now, we're told with data tables, the independent variable, okay, that's the one that we are testing. You guys remember that? And the dependent variable, that's the one that we are measuring or observing. Let's not forget that. The independent variable is on the left, okay? So let's see here. Jenna, which is the independent variable that it's got to be the one that's on the far left? Time in seconds, right? Not meant to be a trick question, but like, okay, cool. Do you remember independent variables, what axis they go on? Do they go on the Y or the X?
Y.
See if Jenna can help me. Do you remember? Want to phone a friend?
Only.
Uh-huh.
Okay. It goes on the. You said the independent variable.
Independent.
Give me a second.
She's thinking. Concentrating so hard. Oh my, this got dramatic. This got serious.
The x-axis.
The x-axis is correct, the one that's on the horizontal. So sometimes I like to slap a little x right there just to remind myself, look at that. You know, that was a moment of anticipation, like, oh, where's she going to go with this? So that means your distance must be on the y, okay? That means your distance must be on the y. Now guess what? I gave you a rubric on your quiz, and today's worksheet, as a matter of fact. Here it is. You'll have the exact same rubric on today's worksheet as you do on the quiz. So here are all the things I'm going to grade for, okay? These bullet points. You want a perfect score in your graph? Here's how you get it, right there. So step one, get a descriptive title at the top. All right, going to my graph paper. My title should say something about my two variables. There are a lot of things you could say here, okay? Personally, I mean, you really don't have to write this exact same thing down. I put rockets distance traveled per second. Zeke could put meters traveled over time, or something like that. Like, there's a lot of options you can put, but talk to me something about distance, something about time, okay? Does that kind of make sense? So just because you don't have the exact same words I have doesn't mean you won't get full credit for your title. All right, sweet. I got a title. Boom. This is me. I'm going to my list. I'm just going to go ahead and check this off. Title, check mark. Done. So that way, I won't forget. Be like, all right, I got a check mark. We're good. Labels on each axis. So we got to label our axis. Okay. And Trini, what goes on the x-axis again? Which variable was it?
Independent.
In this case, that would be?
Oh, the time.
You got it. So I'm slapping time right there. Great. Okay. Now let's see here. How about Christian, who's a Chris? What variable is going on my y? You got it? Distance. Okay. so I got those labeled. Wonderful. I'm going back to my checklist. I'm like, awesome. Labels on each axis. You know it. Independent, check. Dependent, check. Now it says proper units. Oh. So we're back here. Wait, time like, like days, hours, months, years? What are we talking about? Seconds, okay, so you got to tell me that. Put in parentheses afterwards. Now, if Ian puts SEC, okay, that's fine. If Ellie just puts a capital S, that's fine too. I'm not going to get confused, okay? I'm not going to see a capital S, be like, what she mean, hours or something? Like, I know she means seconds, okay? But you got to be clear. You got to let me know which one it is. Juliana, what kind of units are we talking about with distance? Mm-hmm. What is our distance in for our rockets? You got it. So I'll just put a little M afterwards, meters. I'll let Mr. P know. Hey, there's no doubt this is distance in meters, time in seconds. No doubt. Yep.
Sorry,
You're all good. What's the question?
I was gonna ask why is it miles? I mean, why is it meters instead of miles?
That is a great question. The only reason is because my data table told me. See how it says meters right there?
But like, isn't that like?
That's just a different way to measure distance. And this particular person happened to put their numbers in meters. So that's what we're going to graph. Does that make sense? Yeah, no other reason other than the data table tells us. Yes, sir?
How can you tell that M and then miles?
Miles abbreviation is MI. Yep. Good question. Those are both good questions. I love it. Love it, love it. Yep. Okay, so I'm on my checklist. Boom. You want units? I got you some units. This is the next step that is the hardest in my opinion. The scaling. The scaling, okay? Now, I want to be really clear about something. You've been told as you're growing up, hey, beauty is on the inside, not the outside, okay? I'm here to tell you that that is wrong for graphs. Graphs are only as good as they are pretty on the outside, okay? If the graph isn't pretty, you have defeated the whole purpose of a graph. A graph is supposed to be a visual that gives you an idea of what happened in like 2 seconds, okay? They should be pretty. They should look nice. They should be clean, okay? If you have an ugly graph, you're going to get an ugly score on your quiz. Does that kind of make sense, okay? So beauty's on the outside for graphs. For graphs, okay, all right. So we need to make sure our scaling is good. If our scaling is not good, our graph will be rough. So we need to basically pick numbers for our y-axis and our x-axis that make us take up this whole graph. We don't want a graph that looks like this. That looks something like that, okay? That's only taking up this much space. We need to take up the whole thing, okay? We don't want all of this to be empty. We want the whole thing to be filled up for the most part. Does that make sense? And so we do that by picking the right scales. So that's what we're going to do right now. Let's take a look at our data. Our data will always tell us what scale to pick. Okay. We got to go up to at least 36. What's a number a little bit more than 36 that's clean and easy to work with?
40.
40. I love it. You guys are right on it. Yep. So we're going to go to 40. Okay. With the rockets, this one goes up to 98. This one goes up to 89. What's a number bigger than both 89 and 98 that's clean? 100. Yeah, you're on it. People knew exactly where I was going with that. Okay. So our x-axis should go to 40. Here's me. I'm over here. All right, so my x-axis, I'm going to kind of divide them. So my x goes from 0 to 40. All right. What's halfway in between 0 and 40?
20.
Great. So I'll put a 20 halfway through. I can add another one where halfway between 0 and 20 is 10. There we go. Now, what if Bryn, she wanted to go by 5, so she has 5, 10, 15, 20. That's fine. I got no problems with that. Okay? You just got to make it nice and clear so Mr. Pilcher has no doubt. Like in 2 seconds, Mr. Pilcher can tell exactly what this graph is about. Okay? Alrighty. Now my other scale's got to go up to 100. So on the other side of this line, I got a 0 as well. I got a 100 up here. So there's 20 little tick marks going up. So that means each one, if you do your math, has to be 5. Yeah. So if each one's 5, that means every other one's 10. So I kind of did something like this. Now again, if you're Evelyn and you just went by 20s, you're like 20, 40, 60, 80, 100. That's good. That's fine with me. Okay. Honestly, the only thing I don't want is for you to label every single one, because that gets kind of messy. Okay, you have all those numbers smushed into each other. So give me something like this. Bless you! I know who that is. Find out. My guy. Never seen him in my life. All right, cool. Good talk. Somebody sees out in the hallway, those listening at home. All right, cool. Now we're going back through our checklist here. All right. Mr. Pilcher want a scale that takes up 2/3, 3/4 of my graph. You got it, big dog. Boom, check mark. Now, data points clearly visible. Okay, so I want to make those visible. So let me go ahead and take a look at my data points here. Boom, boom. All right, so I got to get some big juicy data points. Now, don't draw this one, but they don't have to be enormous, but make them kind of juicy. So that way I have no doubt where they are. Again, you shouldn't put one right there because that's not on your graph. I'm just saying as an example. Now, here's the thing. One thing I want to note is that there are actually 2 rockets we got to graph. So if you use your same colored pencil for both of them, I'm not going to know which one's which very easily, right? So here's what I suggest you do. And here's what the rubric will tell you as well. Key, if needed, when you have more than one set of data. In this case, we got more than one set of data. We got rocket 1 and rocket 2. So you should pick a couple colors. Now, one of your colors can just be your regular pencil, okay? One of your colors can just be your regular pencil. So maybe use gray for one and red for the other. That's up to you. In my case, I picked red for my rocket 1 and green for my rocket 2. Bryn could use blue and yellow. Okay, and now I could use black and yellow, whatever. Just pick 2 colors that aren't that similar. And one of them could just be your regular pencil color, okay? Because that's like kind of like a dark gray. So if you want to go dark gray and an orange, whatever. It's fine by me. So I'm going to go ahead and put my points on there. Rocket 1 in red. See that? Now please notice with me how you guys can see the individual points on rocket 1. See, there's a point there, there, there. See how they're big kind of juicy dots? So that way Mr. P always knows where my data points are. Does that make sense? And Mr. P is also like, wait, is that rocket 2? No, it's rocket 1. I clearly said rocket 1 is red. And then you can come in with your rocket 2, get some green, boom, just like that. Let's go ahead. Let's put 2 or 3 minutes on the clock. I want you guys to finish that first graph, okay? Finish that first graph for me, then we're going to talk about the second one. All right, so you guys have had enough time to make that graph for your first data table with rockets 1 and 2. Now, it's come to my attention I accidentally switched my colors. So I'm a goof. So I'm going to go ahead. Rocket 2 is actually in red, and rocket 1 is actually in green. So that's my bad.
Oh, that's what I'm saying. I was trying to follow, bro.
I switched them, and the data point should be the same. That's my bad, though. Thank you, AJ. But anyways, one more thing I want to mention. Now, on your test, I will ask you guys, or I should say quiz. The quiz is this Thursday. Your Unit 1 test is until a week from today, next Tuesday. On your quiz, I will ask you this question. Is this graph indirect or direct relationship? Okay. A direct relationship, here's what a direct relationship is. If your 2 variables go up or down together, like if they go up together and down together, that means they're direct. They're directly tied to each other. If one goes up and the other one goes down, like a seesaw, and vice versa, that's an indirect relationship. So here, as time goes up, as we go to the right, as time goes up, what do the rockets do? They go up, right? Okay, so if they're both going up, what kind of relationship is that? Direct. You got it. Okay? This is a direct relationship. On your quiz, you won't have to write that on your graph. I will give you a place where you can just circle direct or indirect, probably. Something like that. I just want you to know that's a direct relationship. Now let's talk about this next graph and how to scale it, because this one's a little tricksy. Okay? So this other one, we just have time and mass. That's all we're given. So which one of these is our dependent? Which one of these is our independent? Let's see here. Independent's the time, Giovanni. That's right. So it will be on the x, and the dependent is the mass. Okay, that'll be on the y. So this is me. I'm flipping to my graph right now. I'm like, all right, sweet. Time is on the independent axis again. That's going to be my x. And what was the time in again? Was it hours, minutes, days?
Seconds.
Minutes.
Minutes. Which
Wait,
one is
what?
it?
Oh
It's
my
minutes
God.
this time. It's
Oh,
minutes this time. Watch out for that, yep. I knew I was going to get some of that seconds, yep. How do you know it's minutes now, not seconds? I'm graphing this guy right here, and this data table tells me minutes. Before it did say seconds, but now it's minutes. Okay. So anyways, so it's in minutes. The other one now is in grams. It's mass in grams. So I'm slapping those labels on there. There we go. Okay. So now let's go ahead and take a look-see at our scales, because this is going to be tough. Well, actually, before we do that, what's something else we can put on here before we forget? The title, baby. Let's get a title. Pretty much any title will do that talks about mass and time. I went with mass loss per minute. Demetrius could just say mass lost over time. Or, you know, grams lost every minute, something like that. Any of those would be fine. Any of those would be just fine. Now let's talk about those scales, though. Let's talk about those scales. This can be big. Easy place to make a mistake. All right. So time goes from 0 to 90 minutes. What's a little bit bigger than 90 minutes, but is a nice clean number? 100. Great. So we're like, okay, Mr. P, that's easy. That's just like the last one. You're right. That one is easy. So this next one. Okay, so our highest number is 19.4. So what's a little bit bigger than 19.4, but it's a clean number to work with? 20. Yeah, let's go with 20. 20 is good. But do you notice how this only goes down to 16.8? Do you see that? Okay. So yeah, so we should just go to something right below that. You could use 15 or 16. I kind of like both because 15 you can divide by 5, 16 you can divide by 4. Either one would be fine, okay? You can do either one. But if you don't want to go to 0. Here, I'll write this for a second. You shouldn't write this, but here's what would happen. If you're like, let's say, okay, everyone's like, all right, let's go with 0 again. I love going with 0. Okay, you're like, fine. Well, let's see what would happen. If you had a 0 here and a 20 here, that would put 16 around here. All of your numbers would be in this range. They'd be up here, and then that would leave you with a blank graph. Like all of this would be blank. And that's not using very much of your graph. That's just using the top part. So we want to avoid that, okay? Because that's just kind of a straight line. You're like, is that going up? Is that going down? I can't really tell what's going on. So that's why we don't want that to be our scale. Erase all those. There we go.
So it's not going to move.
It's not going to go down to 0. And how do you know that, Mr. P? Well, I'm just looking at the data. Like sometimes I'll go down to 0 because it works with the data, but sometimes if my number's only between 16 and 20, like
Oh, you can start at.
you can start whatever you want. Whatever works well with your data. Whatever you want. So some people might start at 15. Some people might start at 16. That is up to you. I'll start with, I don't know. I'll go 16. I like dividing by 4. I don't know. That's up to you guys. So I'm coming back over here. Remember, I'm going to draw my little line sort of separating the two. I'm going to start with 16 on this side and 0 over here. So, all right. Well, if this is 100 minutes, that would make this 50 minutes. And I got 60, 70, 80, 90. Okay, so my minutes are good. So now my mass, if I start with 16 down there and 20 up here. Okay, what's halfway between 16 and 20? 18. Okay, so my halfway point, which is there, it's 18. Mr. P, how do you notice your halfway point? Well, there's one, I'm counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 steps up there, so I just put it halfway up. And then I can do the halfway thing again, 1, 2, 3, 4. So I can know that 17 goes there. 1, 2, 3, 4, 5. I can know that 19 goes there. There we go. Now my scales are going to be solid. Yes, ma'am. What's that?
It says 150.
Oh, that's just bad handwriting, that's all. Yeah, not supposed to say 150. There we go. I'll clean that up for you a little bit. There we go. Okay. So I want you guys to go ahead and knock out the rest of this graph. But does that scaling make sense to you? The scaling's really big. You want the graph to take up most of the graph paper. So I'm going to give you guys several minutes. You can finish up the first graph if you didn't quite get there. And I also want you to knock out the second graph for me, okay? Several minutes. I'll come around, check in on folks, see how they're doing. So I want to make my data points nice and juicy. 15 minutes. So I'll be on this line right here, 19.2. So that's right here. Got a big juicy dot right there. 30 minutes, 18.9. That's going to be just below my 19. 45 minutes, 18.6. Here we go. 60 minutes, 17.9. I'm going to show you a couple more things, and I'll let you guys pack up. So don't pack up quite yet. I'm going to show you a couple more things. And you'll probably have an extra minute or two to just hang out after class, okay? Or after I'm done talking, I should say. 75 minutes, we got 17.5. So this 17.5 is going to be a little bit above that. And then lastly, at 90 minutes, we got 16.8. So it's going to be right below my 17. There we go. Now, watch this. My line doesn't have to perfectly touch all my points, but I just want to put a line in there to smooth it out. See how I'm kind of smoothing things out? That way Mr. Pilcher can kind of see the general direction of how things are going, okay? So it kind of missed this little dot up here, but that's okay. Mr. Pilcher can see which direction this is going. Now, do we have a direct or indirect relationship between our mass and our time here? Yeah, Lindley? Indirect, how do you know that? Yeah, the mass is going down while the time goes up. So they have an indirect relationship. They're doing the opposite thing. So below your graph where it says direct or indirect, you guys want to circle indirect. That's what you guys want to circle below your graph. You guys see that little spot right there? Get used to that. You'll see that on your quiz. You have a little spot to circle it. So that's that. Tomorrow we'll probably practice graphing a little bit more. And then I'm going to give you some ready-made graphs, and you're going to tell me what they mean. All right? So that's a wrap for today.